Hello folks, fellow YouTubers and friends. I'm going to demonstrate on how I go about dividing a straight line into as many or as few segments or equal portions as I wish. One of the things that you can do by doing that is, for example, I think a few of you have seen my videos on how to convert a ceiling fan into a PMA, permanent magnet alternator. And what you simply do is take a piece of band iron. I just had this laying around so I used it. I prefer the newer type band iron to have this plastic. It doesn't stretch very much, and especially for doing something like this, and it does bend a lot easier than this. Ceiling fan stators have so many coils in there. You simply count the coils, you wrap this band iron around it, get the total length around, and in this case it has 14 coils. I'm not going to do that many on the line because what I'm doing, no matter what, it will divide a straight line of a given length into as many segments as you want. It all depends on how you do it. Okay, I'm going to divide this one 5 times. Okay, so what we're going to do is take this and just pretend that the ceiling fan has 5 coils, and that's where we want our magnets. Okay, so what we're going to do is we're going to place this up here. We've already got it marked. Oh, right. I can't see it. There it is. Right there, and on the very end right there. Okay, I'm going to make these darker so you can see them, and we'll wipe this off. Well, at least I thought I would. Let me get some alcohol up here. There and there. Okay. Anyway, the process is so simple, it is absolutely pathetic. You simply go from this point and just draw an angle, and it really doesn't matter. I mean, just draw an angle. Put your needle right there and make an angle, like so. Okay, now you got that. So now what we need to do is take the dividers and construct an angle down here exactly the same as that. That also is super simple. Just put your dividers, open them really wide. Put it right there where they cross. Make a mark right there. Come down here. Make a mark there. Then reset the dividers to here. Come down here. Oops. Didn't make it long enough, did I, folks? Okay. Okay. But first off, I want to let you know that if there's any inaccuracy whatsoever, it is not the system or the way we're doing this. It's simply the thickness of the lines. Now, if you look at my dividers, when I actually do this out in the shop, the dividers have really sharp points on them. Okay? And it's a very small scratch line, so there's no width to contend with. Alright. So let's draw our line down through there. Okay. Now, this is the super simple part right here. we want to divide this into 5 equal parts. So all we have to do is guess at anything that's a little over 1/5. So that's 1, 2, 3, 4, 5. That's not enough. 1, 2, 3, 4. That's plenty right there. Alright, so you want to divide it into 5 equal parts. You simply start here and you mark this. 1, 2, 3, 4, and 5. And we don't pay attention to that. Alright. And then come over here and do the, down here the exact same way. 1, 2, 3, 4, 5. Now, here's the thing, so you don't get confused. What you really want to do is take your very last mark to the end. That establishes the end. Otherwise, some people, in fact including myself, from time to time will get confused and start drawing lines in the wrong position. Okay? So there's the ends right there. Okay, then it's just a matter of lining them up and drawing a line through where they cross. There. 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 And there. Now, if you'll check, each one of those is exactly equal, and there's 1, 2, 3, 4, 5 segments of that line. And if we set the dividers, just for a quick check, there, 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 and there. And that will work no matter how many segments you want to divide it into. Your given line is this line right here. This, just in this particular case, just happens to be the circumference of the ceiling fan. Now, had I cut it down to the exact same length and just made 14 marks here and 14 marks there, you still would have divided it into 14 equal sections. And then you would simply take your band iron or plastic, whatever, cardboard, put it back up there and mark each one of those, wrap it around your ceiling fan and make your marks. And that way your magnets will be exactly, I mean, within 1/122 of an inch. If you use little tiny scratch lines, it'll come out, I mean, almost perfect. A machinist could do better, but what the heck. A lot of you guys are like me, you're shade tree mechanics, backyard inventors, and would-be scientists. Okay, so anyway, that's the simple way of doing this. And in the future, I'm going to show another video. In fact, I don't even know if I'm going to show a video. Well, yeah, I will too. Do it right now. I've got a bunch of round discs that were cut out by CRC machines in the company, and then they were scrapped because they were the inside of circles. So they're round discs, okay, and they have no center. And I showed people this on one of my other videos, but it was over my shoulder and so forth. And I just want to just halfway do it so that people will see and understand, hopefully. Let's just say you have a circle. If you don't know the center of the circle, which we will with this, okay, now it does not matter what chord you draw. A chord is a line that goes through a circle that does not pass through the center. If it passes through the center, it is a diameter. However, it's still a chord. But a chord is any line that passes through a circle on the edge. So in this case, And here's another thing too. In this case, there's a cord. Now, we don't need to know the length of the cord. All we need to know is that it terminates on the edges of the circle. If you take a pair of dividers and construct a perpendicular bisector to that cord, any cord, and the thing is, 2 will give you the center, absolutely center. And like again, it doesn't matter how long they are, where they are. The thing is, they can even cross one another if you want. It doesn't really matter. The third one is only for accuracy, for a double check, because 2 will give you dead center. Now, that perpendicular bisector, if we drew a line through here, it will go through center. If we drew a line through here, it will go through center. And the third one is for a double check. That's all it's for. Okay, so in this case it's these, and then this one. Oh, I just put it on. Yeah, there it is, there it is. And these two, right there. And that's how you find the center of a circle that has no center. Okay, we're going to be using that a lot, okay? And I'm going to make this the end of this video. However, tomorrow, today being the 24th of December, 2014, tomorrow I'm going to clean this board, set it up, and I'm going to show you the easiest way I know how. Now, just like anything you do on a computer, there's 4 or 5 different ways of doing it. Anything you do in geometry or mathematics, there's 4 or 5 ways of doing it. I mean, just because you do it one way and I do it another, doesn't mean your way's right or wrong or my way's right and wrong. It's what works for you. This works for me. This gets me dead accurate. What I'm going to do, I've searched the internet for weeks now, even months, trying to find a formula to divide a circle into any number of segments I want. For example, just say I have this disc right here. It has no center. It's 11 3/4 inches diameter. Let's just say I want a 10-inch radius, I mean a 10-inch diameter, and I want to put 7 bolts in this, and I want them evenly patterned. This is what I'm going to show you in my next video. The way I do it, it doesn't matter. It does not truly matter how many bolt holes patterns you want to put in this thing, as long as the circumference will withstand it. It's super simple, super. You're not going to believe it, but I'll make that video tomorrow. I'm going to make it with 11 or 13 bolts, and the reason I'm doing it with a totally odd number like that, because anything with 2 holes can be just simply construct a perpendicular bisector of the circle and make it 2, 4, 8, 16, 32, 64, blah blah blah. 3 is simple to do. 2 overlaid isosceles triangles. An isosceles triangle is 3. If you overlay it, you get 6. And then if you construct perpendicular bisectors, then you get 12, 24, 48, so on. However, how do you lay out a circle with an odd number of holes, such as 5, 7, 9, 11, 13, 15, 17. These are numbers that it's almost impossible until I came up with this idea. Now, the one I just showed you right here, I found this on the internet the other day, and it was posted on the website by a guy by the name of Wayne. By the way, Wayne, thank you very much. It's super simple. I love it. Thank you. But what I'm going to show you tomorrow is so simple, you're going to flip. And it's all my own doing. I mean, it took me, I don't know, time after time to try to figure this out, but I finally got it. It's so simple, you can get your bolt hole pattern within 128th of an inch. It's that simple and that accurate. Okay, until tomorrow, folks. Goodbye. God bless. Have a good day.